Hello, so we're here talking about molecular formula. So if you're doing a molecular formula, you have probably already calculated the empirical formula. And if you have not already calculated the empirical formula, you might need to go do that first, depending on the question. So many questions ask you to do both the empirical and molecular, and you need the empirical in order to do the molecular. So keep that in mind. If you don't have the empirical formula, go get it. Go do that work. Maybe go watch that tutorial video if you need to in 7.4 before you do the molecular. In this case, we are already given the empirical, which is nice. So when I'm given an empirical, remember the empirical is the simplest form. The simplest form. Sometimes the simplest form is the actual molecule, but sometimes the actual molecule is a bigger version of that form. So like hydrogen peroxide is H2O2. The simplest form of that would just be HO. I can divide both of those by 2. But in reality, it's H2O2. Or glucose is C6H12O6. In reality, I could divide all of those by 6 and get CH2O. That would be the empirical formula. But in real life, the molecule is C6H12O6. So sometimes empirical and molecular are the same and sometimes they're not. Here's how we figure it out. So I need to add up the molar masses of my empirical formula. So I've got one C and one H. So C carbon, that's a molar mass of 12.006, plus our H is 1.008. So I end up with a molar mass of 13.014 grams for every mole. Then I'm going to take my actual molar mass, I'm going to divide that by the molar mass of the empirical formula. So I'm trying to find the ratio. How much bigger is the molecule than the empirical formula? I can tell it's bigger. I mean, 78 is bigger than 13. So I just need to know how much bigger. So I divide that out and I get 5.99. Okay, so 5.99 is 6. If it's a 0.99, round it up to the whole number. So that equals 6. So that means when I write my molecular formula, it's going to be 6 times this. So instead of being C1H1, it's C6H6. C6H6. So I remember, just to recap, I added up the molecular formula, I added up the empirical formula, the molar mass, divided it by the molar mass of the molecule, multiplied by that factor. So let's try again. I've got NO2. So N, that's 14.006 grams per every mole, plus O2, so 15.999 plus 15.999. Make sure you add it up based on the formula. There's 2 O's, so I need to add 2 O's here. So that gives me 46.00 grams for every mole. So I'm going to divide my actual molar mass by that empirical molar mass. And that one we should be able to do in our head. It's just 2. So the molecule is 2 times bigger than the empirical formula. So instead of writing N1O2, I'm going to write N2O4. So it's the same ratio. It's still a 1-to-2 ratio. I just doubled it because I could tell that my actual compound was twice as heavy as my empirical formula. Now, if this number comes out to be 1, it means that the empirical and the molecular are the same. And again, that does happen sometimes. So sometimes the empirical and molecular are the same. You get a ratio of 1, and in that case, you just leave it. You don't have to change anything. But just to recap one more time, you add up the molar mass of the empirical. You do the actual molar mass divided by the empirical molar mass. And whatever that comes out to be, you multiply your empirical formula by that. And that's how you get the molecular formula.